Hello, algebra students. Mr. Lawrence here, and we're going to review factoring. Spend the next couple days factoring. It is part of the park, and I heard from the high school teachers that some of the kids aren't retaining factoring well enough, so I thought, well, you know what? I'm going to go over it again. And the first two types we're going to do are perfect square trinomials, which you should be pretty good at because of the completing the square technique, and then difference of perfect squares, which I really don't understand why kids struggle with it other than they don't know their perfect squares. And I've told you, you need to memorize them. They're very simple. Okay, you need to take some time. It doesn't take long. But if you go 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. Those are the first 10 perfect squares. How do I know? Because 1 squared is 1, and 2 squared is 2, and 3 squared is 3, etc. Okay? Then after 100, you've got 11 squared, 121. 144 is 12 squared, that's gross. 169, 13, 196, 14. 15 is 225. 16, where are we at here? 256. 17, 289. 18, 324. 19, 361. And 20 is 400. Now, of all of these, okay, you should know through 12, no problem. These two are relatively easy to remember. One's 169, one's 196. Okay, 225 you need to learn. 400 you should know. So you've got 1, 2, 3, 4, 5, 6, 7. Oh, excuse me. 7 perfect squares to memorize. Just do it. Write them down. Don't be so lazy. Instead of watching TV or playing that video game or texting or whatever it is, write them down. Practice them. They will make your life so much easier in mathematics. Start recognizing them. All right, so first we're going to do a perfect square trinomial. And notice it's in standard form. Okay, when A and C are both perfect squares, so A is 1, right? Or actually, yeah, that's okay. The lead term is 1x squared. And then 9 is a perfect square. Okay, what's the square root? Well, that's 3. And the square of that is x. Multiply them together, 3x, double it. If you get the number there, the b spot, the bx spot, then you've got a perfect square trinomial, and it'll factor as x plus 3 quantity squared. Now, I've got it equal to 0, so that means I'm going to solve it. Okay, and if I want, I could write it like this. It might be easier to solve. And then I don't really have to set both parts equal to 0, both quantities, because they're identical. But it's not wrong to set them both. It's just to do it twice is kind of silly because you already know it. But if you did it, it wouldn't be a big deal. You're just going to get the same answer twice. That doesn't mean there's 2 answers. That means there's 1 answer. Okay? So I'm not actually going to do this a second time. Oh, excuse me. So this would be a parabola with 1, 0, right? 1 x-intercept, and the x-intercept would be at x equals -3. The parabola would be sitting on the x-axis, opening upward because a is positive, right? Because there's a 1 there. Okay, so you see this all ties in with things we've been doing all year. All right, let's do another perfect square trinomial, and then we'll talk about the difference of perfect squares. Looks like I didn't give myself enough room here. Hold on a second. Let me group all that together, and I can move the whole thing down. Okay, so I've got this trinomial. I'm not sure what's going on here. I lost my pen. Okay. Well, what is going on? All right, there we go. Let me move that out of the way. Oh, what is that? 6x. Oh, that moved. That was interesting. Funny. Not sure what happened there. Let me group that all together so it doesn't separate again. Okay, now let's see if I can. Yeah, I've got my pen back. Okay. So I'm not sure what the problem was, but the problem seems to be fixed. So I've got this trinomial. I notice I have a perfect square here, and I have a perfect square here. I find the square root, 3x. I find the square root, 5. Multiply them together, I get 15x. If I double it, it matches. I get 30x. This is a perfect square trinomial. This will factor 3x plus 5 quantity squared. Or if you prefer, you can write it as two quantities. It might be easier as two quantities to go ahead and solve it that way. Now I only have to take the one quantity, set it equal to 0. By the way, you're only going to have to solve if it says solve. It will be equal to 0. It won't say, factor and then expect you to solve it. Factoring would just be doing this part here or this part here. Okay, so now when I solve this, I subtract 5 from both sides, and I get 3x equals negative 5, and then divide by 3. And so x will equal negative 1 2/3. Okay, again, this will be a parabola that sits on the x-axis. Oh, I apologize. Sorry, just getting over that cold. A is positive, so it's opening upward. And I know the 0, the x-intercept, is at negative 1 2/3, 0. Okay? All right, let's talk about the difference of perfect squares for a minute. Here I have x squared minus 9. This is actually easier because if you have a perfect square minus a perfect square, all you need are the square roots of the two numbers. And then you're going to get two quantities. It's going to factor like this. Okay? X plus 3 and x minus 3. Now, because it's equal to 0, I need to solve, so I'll set each quantity equal to 0. And then x will equal negative 3 and x will equal 3. So this parabola has two x-intercepts, 3 and negative 3. It is opening upward. Okay, I think the vertex will be at 0, negative 9, but you can verify that if you like. So this is how it factors, and this is how you solve it. All right, here's this one here. Again, I have a perfect square minus a perfect square, square root 4x, square root 5. So I'm going to have 4x plus 5 times the quantity of a 4x minus 5. It's completely factored now. It's equal to 0. I'll solve each piece. Oops, don't like that little mark there. Let me get rid of that. Started to make an unnecessary parenthesis. Trying not to blow out your eardrums there, holding a cough. Hopefully you're doing okay. 4x is going to equal negative 5. Divide by 4, divide by 4. X is going to equal negative 1 1/4. And then 4x is going to equal 5. Divide by 4, divide by 4. X is going to equal 1 1/4. So again, it's a parabola. It's opening upward. Has two x-intercepts. They're at negative 1 1/4 and positive 1 1/4. There you go. Okay. Now, I've got 4 more problems here. I want you to do this as a video quiz. So there's 1, 2, 3, and 4. And you need to have them done tomorrow. And they're going to get checked for credit. Okay. So, by the way, there's a trick in here. Notice that on 1 and 3, the B term is negative in both cases. I didn't do any examples like that, but you should know what to do with it. And be careful with number 4. I might just try to be tricking you. All right, so that's it for the video. Mr. Laurence signing off. Have a good night, everybody.